This is October-November 2025, paper 1-2. These are the variant grade thresholds. So reasonable estimate for the weight of a human being. So we will be using the equation W equals mg. And looking at these numbers, it's quite obvious that he's trying for 70 kg. So even if we try for g as 10, there should be 700 newtons, which can be written down as 7.0 or 7 into 10 raised to power 2. The answer is going to be very easy. It's going to be option B. Question number 2, what describes the set of data with high precision? High precision means high repetition or high repeatability. The reason we are thinking about high repetition or the ability of high repetition is because we want to be able to predict the future value with high confidence. So even if the value is wrong, even if the value is right, the fact that the experiment gives me the same answer for same data set again and again gives me the confidence that I can do the predictions in the future with high percentage of hitting the target, of hitting the mark. So that's all the repetition is about. So first thing is about small scale division. This is called the least count. In some sense, it does mean precision, but since we are talking about the set of data, not an instrument, we will shy away from this option and go forward looking for a better one. Data that is close to the accepted value. Now this deals with accuracy. Part B, have low uncertainty, again deals with the accuracy of the data. Data that repeats that are close to each other, or being close to each other, or having the ability of repetition is what is going to be precision or qualify as precision. Question number 3, what quantity could have units of Newton second square per meter? So since there is a Newton in there, it's quite understandable that they are not going for the base units. The acceleration would be ms minus 1. Force would be newtons directly without any involvement of this. Momentum will be kg ms minus 1. And obviously we can't combine them together. So let's give it a try to mass. Now it will appear very obvious using the equation F equals to ma that F is Newton, mass is what we want to find out, and acceleration is meters s minus 2. So when you take this to the other side, the unit for mass comes out as Newton, m minus 1 and s square, which is similar to this one, which is why option C is the right answer. Now see questions to throw you off the balance, but anyways, a ball is released from rest, so the initial speed is going to be 0. Time taken to fall, that distance are both measured. Okay, so we're measuring the time taken and the distance, so we're measuring s and t for the equation's sake. The percentage uncertainty in measured distance is negligible. The percentage unmeasured time is 4%, so t will be plus minus 4%. Distance does not have any issues in it. The distance and the time used to get acceleration of free fall. So we're looking for the acceleration A in the equation. Air resistance is negligible. What is the percentage uncertainty in the acceleration of free fall? So first we need to find out what equation we're going to use. So we're going to start with, since there's an involvement of s and t, we're going to start with s equals to ut plus half at squared. Since it is being released from rest, this part becomes 0. We are left with s equals to 1 by 2 at squared. Since we want to find the acceleration of free fall, a will be the subject of the formula. Let's take 2 to the other side. This becomes a equals 2s divided by t squared. Now, they themselves mentioned that the distance has negligible percentage error. So all the error contributed to a is because of t squared. And time error is 4%. So dealing with this in terms of the power rule, the error function will look something like this. Change in a divided by a equals change in s divided by s plus 2 times change in t divided by t. This, he says, is negligible, so this becomes 0. So the only error contribution is because of time. This delta t by t multiplied by 100 is given to me as a percentage over here. So the answer for this question will be 2 times the percentage error, which is going to be option C, 8%. Question 5, a car initially has velocity u, then moves to a constant speed a in the line through displacement d, the car final velocity v. Which expression gives the initial velocity u of the car? Now, based on the variables that we have already, we are confident that we can use v square equals to u square plus 2as. Now, since he's asking about the initial velocity, then we can bring this to the side. This becomes v squared minus 2as u squared. Taking the root to the other side, this becomes u equals to root v squared minus 2as. Now, it's only about matter of replacing the variables. He says the displacement is d, so s becomes d. And the most closest possible option is option B. Question number 6. Now, question number 6 says, bicycle brakes, uniform deceleration, keyword, speed from 8 to 6 over distance of 7 meters. The deceleration remains constant. Which further distance will the bicycle before coming? Now, before we move on, we need to find the acceleration first. So this will be simply found by, since we have distance involved, this will be v squared equals to u squared plus 2as. Final speed is 6, initial is 8. Since we are looking for deceleration, the answer will be positive or taken out positive. So this will be 6 squared equals 8 squared plus 2 into a into 7. This happened in a distance of, or displacement of, 7 meters. So when you do the algebra correctly, I understand that this, when goes to the other side, is going to yield a negative result or negative value of acceleration. But you don't need to worry about that, because deceleration means it is inherent that even with a negative value, we can write this down as simple a, which is going to come out as a equals 2 meters per second square. You see, if I write down acceleration, if I refer to this as acceleration, I will write down negative. If I refer to this as deceleration, then writing down negative does not make any sense. All right, so acceleration or deceleration, to be exact, is known now. The final speed before all of this was being counted or is being asked from us is 6 meters per second. He says before it comes to rest. So now the initial velocity becomes 6, the final velocity becomes 0. The acceleration is given, and we want to find the distance traveled by the object. Now in this case, the very straightforward and obvious equation is going to become v squared equals to u squared plus 2as. V this time is 0 because we want to make sure that it comes to rest. U is 6 squared because this is what the situation was before we dived into the next part of the equation or next part of the system. Plus 2 into acceleration, which was this part. This is 2 into the displacement s. Now again, if you put negative sign, if you ignore and you just take this as a concept, you can ignore the negative sign in this. If you take 6 to the other side, becomes negative 36. And then that negative dealt with this negative of acceleration will eventually lead to an s value of 9 meters. The correct answer is B. Question 7 is interesting. It says velocity time graph an object is known, total displacement. Now, for a velocity time graph, the displacement or the distance for a speed time graph is usually the area under the graph. Okay. Now, this area is generally more, so I can see that the area 1 is greater in terms of values as area 2, or in comparison to area 2. Now, what options can I go for? Area 1 plus divided by 2, this is incorrect. We don't need to do that. Area 1 plus area 2, this seems like a plausible option. Area 1 minus area 2, this also looks like a plausible option. Then area 2 minus area 1, no, that doesn't make any sense at this stage because it will yield a negative answer. Yeah. The total displacement, yeah. Because area 1 is not negative. Okay. Now, why are we rejecting these options and why are we confused about these two? You see, the total displacement, total means there should be an addition sign. So if I were to find the area of the area 1, that would have been area 1 plus, because we're finding the total, into negative area 2. Why is it negative? Because it exists on the negative side of the velocity. So whenever I use values for v, it will give me a negative answer. This is the true understanding of the total displacement, which leads to option A. This is why we rejected option D, because technically speaking, this is fine. There's nothing wrong with it. But the problem, the fact that area 2 is being given a positive value and area 1 is being given a negative value, does not make any logical sense. And this is exactly why this question was confusing. Okay, question number 8. What is the weight of the object? So these questions are generally dealt with the definition part. So it is equal to the mass, not by its acceleration. It's supposed to multiply it by the gravitational acceleration. So the first part is right, but the other part is wrong, even if it was the right answer. Is equal to the resultant force when the object, no, it's not. It's not. Even if the resultant force there is, It was 0 because at terminal velocity, the resultant force is 0. And the weight is not 0. It's always acting at all times. C, the force acting on object due to gravitational field. This seems like a good answer. It is a property that, now this is the property of mass. The resistance change, and the technical word for this is inertia. That's not the definition for this part. So for weight, the best answer will be option C. The reason we rejected this is not because it's acceleration, it's gravitational field acceleration. Question number 9. What statement is the principle of conservation? Again, a definition or some rule, some law, some definitions. In elastic movement, the momentum is constant. Instead of saying constant, we better use the word conserved. But this is not the right answer. Even in an inelastic collision, the momentum is still conserved. So it is limiting myself to one option, which is not right. Momentum is product of mass and velocity. This is true, but this does not define the conservation of momentum. It is only defining what momentum is. It's true in its own right, but that's not the answer to this question. A general example that I give to the students is that why this is wrong or this is not acceptable is that I'm asking that what is 5 plus 1? 5 plus 1 is 6. Very simple. The answer option B is giving right now is 2 plus 2 equals to 4. In its own right, this is true, but that's not the answer to my question that the examiner is asking. So keep your mind clear about this. It's not that this option is giving you false information. This is not what the question is about, which is why I am rejecting option B and option A. Option C, the force acting on the body is proportional to the rate of... This is also true, but that's not the conservation of momentum. This definition is for the resultant force, that is delta P divided by delta T, which is true in its own right. Again, rejecting this option. Option D says moment is isolated, system is constant. Yes, this makes more sense because this is related to the conservation fact that nothing is going to disturb the momentum unless something from the outside starts disturbing it. Now, this question required you to dive into more visual nature of the question, whether you're able to figure out what type of resultant will that be, or combined momentum will that be. Notice that this is purely, from 4 Newton's perspective, this is purely the positive x-axis momentum. This one brings in a negative x-axis and some positive y-axis. And just by simple comparison of length, if you just look at the length of this, because momentum is a vector quantity and vector quantities carry information in their length in terms of their magnitudes, this length is smaller than this length, right? If you're trying to make this at right angles, which means that the final resultant momentum will have some axis on the negative side, and there is no contribution from the 4 Newton seconds towards the y-axis. The only y-axis contribution is from the 8 Newton seconds, which is of course at an angle. So the final answer actually has positive y-axis and negative x-axis, which is slightly smaller. So the resultant momentum should look like this. This should be my final answer, which is obviously very close to option B. Why option A is incorrect? The reason, there is some y-axis momentum present, positive y, which is absolutely correct. But A assumes that both x-axes were added together, which is not possible because this one is to the right, which is positive, and this one is to the left, which is negative. Momentum is a vector quantity and it's very sensitive in terms of its direction. Question number 11. A skydiver, favorite question, constant velocity, terminal velocity, opens a parachute. Okay, fine. Which statements about the motion of the skydiver are correct? Let's see. Now, if this is a velocity time graph, then the gradient will show me the information about acceleration. And if I know the acceleration, then I can comment about the resultant force acting on the object at different sections of the system. The magnetic acceleration is maximum at time t2. Now, this statement is true. Be that acceleration, be that deceleration, at t2, I can see that the gradient is the steepest, visually speaking. So if the gradient is very high, the acceleration is very high, which is deceleration, of course, because at t2, they would have opened the parachute. So this statement stands true. The magnitude of drag forces at T1 equals to the magnitude of drag forces at T3. You see, when it eventually goes through the whole process, the drag forces are equal. Okay, so for example, whatever drag was here, because there is weight and then there is drag, if the weight is 30 newtons, then the drag would have been 30 newtons too. At this moment, the air resistance increases because of the more surface area. But eventually, after T3, it again has to settle down towards 30 newtons being equal to 30 newtons. Only then the gradient becomes 0, the acceleration becomes 0, and we can have a terminal velocity situation. So 30 newtons at this stage and 30 newtons at this stage, they should exist, otherwise there will be no establishment of terminal velocity. So second point is also true. Point number 3, a drag force is maximum at T1. Now this statement is false because it is in direct contention to statement number 2. The statement is incorrect physics and also nullifies statement number 2. So the only true statements about the Skydiver are correct is option A. Question number 12 is from the relative speed rule question. I've explained this rule many times in my past paper videos, in my lectures as well, but let's try to apply this over here in this situation. He says the two different blocks are running towards each other. Okay, fine. Horizontal friction. The blocks are elastic collision. Good, which means that I can use the relative speed rule, in which I don't have to involve masses in it and still be able to solve the momentum question. So diagram shows the velocities of two blocks immediately after contact. That's the changing bit. That means that before that collision happened, it's quite possible that P was moving this way and Q was moving this way. Okay, fine. Which wrote possible velocity of the two blocks immediately before collision? You see, because the relative speed rule is in place, we need to calculate this, and the relative speed before collision is equal to after collision for an elastic collision. So at this stage, because they're moving in the opposite direction, 70 and 20, the relative speed after collision, it comes down to 19 centimeters per second. And that's how the rule works. If they're moving opposite to each other, then the speeds add up. If they're moving in the same direction, you have to take a subtraction. So anyways, I've added the speeds. Now, what I'm looking for right now, before collision, all the answers should make 90 the relative speed. If I get the same speed, relative speed, then that will be the situation for it to be in elastic collision. So relative speed in every case, let's find that out. 10 centimeters to the right, 60 to the left. Because they're moving in opposite directions, I can add them. So 60 plus 10 will be 70. 0 plus 50 will be 50. 20 to left and 70 to right, I can add them. So 70 plus 20 becomes 90. And let's say 60 right and 30 to the left. Now, in both cases, I'm getting 90 answers. No, I have to be very careful at this moment onward because they're moving. Now, notice that since this is before collision, it's not possible that object P is moving to the left. If P was already going to the left and Q was already going to the right before collision, then this collision would not have happened in the first place. So this situation, although yielding the same result, may give you the false impression, is wrong because it is wrong situation. The right answer will be option D. Yes, P has to go right and Q has to go left to be able to get into this situation after bouncing off. Okay. Question number 13 is a repeated question. If you've done past paper for the last 10 years, you might have seen this question at least twice or thrice. That's why I recommend my students to do at least 10 years of past papers so that you get or see more familiar questions. Diagram shows a couple. There needs to be a perpendicular distance between them with an angle of 90 degrees. They should be anti-parallel. They should not be passing to the same point, so the line of action of force is different. This seems to be the right answer. Option C stands incorrect. They need to be perpendicular in this sense. Same line of action of force, but opposite. B could be right, but F is in the same direction as this one, so it is going to make a resultant force of 2F this way instead of making this into a couple or torque. Point D is moment or turning effect, yes, but does not qualify as torque. Torque requires another force acting the opposite way. So option A is going to be the most common, best answer. Question number 14 required some form of algebraic manipulation and some visualization before moving on. So it says uniform, when he says uniform bar, that means the mass M will be at L by 2, at exactly the midpoint of this situation. That's why he says the uniform rod. Distance X from the end X, he's explained the situation. An object place M, mass M, is placed at the bar, distance Y from the pivot. Now he's not mentioning where it's supposed to go. So that the bar is in equilibrium. If the bar is in equilibrium, clockwise and anti-clockwise movement should be equal. Now, if this is the weight of the rod, which is, of course, W equals to capital Mg, because we need the force, so another smaller mass should be placed somewhere here. with a value m. Only then we can ensure that it is in equilibrium. So the first thing we have to realize is, let's see that this is anti-clockwise and this is clockwise. Both moments should be equal to each other. So m multiplied by y, because he says that the distance y is for m. So whatever this distance is, it would have been y. Of course, it could be closer, it could be further away, but x is given to be on that side. Equals, since we need all the moments to be from the pivot up to this point, this is the distance we are looking for. And that will be dead center, which is L by 2. So this point to this point is L by 2 now. So if you subtract L by 2 and x, it gives me this distance, that is from the pivot up to the point of the weight of the rod. So that would have been capital M multiplied by L by 2 minus x. Now there is one thing that I would like to add here. Since we are working with forces, yes, we could have added g in this. The m of the smaller mass would also be multiplied by g to get this. But if you multiply g on both sides to find the force, it is eventually going to get cancelled mathematically. So that's why I haven't written this in the final equation. Okay, so let's get down to the business. So he's asking me the equation for y. I need to make y the subject of the formula. So in this case, it will be my equals m into L minus x divided by 2. I'm just doing algebraic manipulation so we can sometimes see, and this will be 2, of course, 2. Which common answer are we going to get? So let's bring this 2 to the outside. This is going to become, and let's make m go to the other side. This is going to be y equals to m over m into L minus 2x as the expression. So let's see which one is the common answer. That's option C. I hope you understand how to make the equation, because after that, finding the correct answer is not a problem. The mass and volume of an object are varied. Which two changes must increase the now, simple density is equal to mass by volume. Mass, if you want to increase the density, then mass can be increased or volume can be decreased. There are two choices. So mass has to increase and volume has to decrease. More compact area, more number of particles in the smaller area leads to higher density. So it's a very easy question in that sense. Question 16 again is scary looking at the equation or the system, but it's not that difficult if you just follow the variables together. So on Earth, liquid experiences UE equals rho GV. On Mars, fully submerged in the same liquid is the same, so the value of rho density will be the same, experiences again rho GV. The acceleration of free-falling mass is 3.7. On Earth, he's not given that to you because we know that's going to be 9.81. Assume that the liquid's density and the object's volume have the same values on Earth and Mars. Use the ratio. So divided by UE would have been rho GV divided by rho GV. Since we're using the same liquid, rho cancels out. That's the density of the liquid. G of Mars is going to be 3.7 divided by 9.81 multiplied by the volume or the displaced volume. Since we're dealing with the same object, it's submerged in both cases. This is going to be V divided by V, which is again going to get cancelled out. We are left with only 3.7 divided by 9.81, which yields 0.377 answer, which is 3.8 option A. Question number 17 is a fact-based question. It's a repeated question. They've asked this question many times in the past papers, and this is how we derive the formula for kinetic energy. You can read the question all you want, but you know for a fact that option C is not needed. Why? Because this is the energy for elastic deformation, half force into distance for as area under the graph. We're only going to get, or we're only going to be using these three equations to get to the equation of kinetic energy, and you can watch my another lecture where I have driven this equation. So I'm not wasting time on this question. It's very easy. You can also find this online. It's not that difficult. Question number 18. It says that the ball, now this was surprisingly a very easy question. I don't know why this was given, but apparently, according to the examiner, some 25% of the students still got that wrong. Now it says that there is a building, for example, the ball was thrown from the top of this building from point X. It falls, so this is 2.4 meters above the ground. The ball rebounds from the ground to rise to point Y. So it falls down and then rebounds to this point, for example, and this total height today is called Y. This is Y. And this is given to you as 1.8, being 1.8 meters above the ground is given. He's clearly asking the change in height or the difference in height. He's not asking the total distance traveled. So this height minus this height yields me this delta H. We simply have to subtract these two values and we will get option A as the answer. In the examiner report, he's mentioned that some students just simply added those two numbers to get the false answer of option D. But the idea is that we're looking for delta. Delta is change. And you do the same thing for MGH. Question number 19 is a very nice question in terms of repetition, in terms of concept development. Work done forces are given to you. The weight of the object is given to you. He says that frictional forces remove 4.2 joules of energy from the system. He says, based on these values and on these idea, what will be the value of H? How high can it go? Now, always take work energy power problems as an accounting problem. It's all about investment. It's all about losses. Also, it's all about profits. That's why the examiner has started using the word store in their recent syllabus. As forms of energy, we use stores of energy because it acts like a bank. But anyways, so let's see how much energy we invested. So work done as an energy investment in the system, that will be simply F into D. Which force is doing this job? 1.8 for how long, for how distance, for how long a distance, that is 8 meters, which is 1.8 multiplied by 8. Now this gives me 14.4 joules of energy investment into the system. Now let's calculate or find the losses of the system. He mentions that 4.8 joules are used as work done against friction, which means as the block was going up to this point, from this point to this point, it has lost 4.8 joules from the system. They are no longer there. So an energy loss of 4.8 joules leaves us with only 14.4 minus 4.8, because you're not getting it back, leaves us with 9.6 joules of energy. If I put this back into mg delta H is what I want to find out. So mg is given to us as 4 newtons. That's the weight of the block is given. Now the only trick is that this is weight, W is equal to mg, mg is 4, so instead of mg we write down 4, delta H equals to 9.6. Delta H very easily comes out as 2.4 meters. But with all the effort from 1.8 newtons in losing some energy to work done against friction, we are still going to be good enough to take this up to a height of 2.4 meters. The answer is going to be option B, second option. Question number 20 again is a repeated question, not in terms of value, but in terms of concept. He said that a motor loads a mass of 600 kg, vertically constant speed, 12 meters per minute. Useful output power. So power is simply equals to energy or work done divided by time. So basically, if you can find joules in the whole question anywhere, you are good to go. Now, since it is being lifted, the energy potential being given in is mgh divided by time t. Mass of the system is 600. The value of g is 9.81. Now, this is tricky. This is h by t. Can we find something similar in this situation or somewhere around here? Yes, we can. 12 meters per minute gaining height. So if I just isolate h divided by t in this equation, as t being with this h only, this makes more sense that this value is given already. So this will be 600 multiplied by 9.81 multiplied by 12 divided by this minute. It has to be in 60 seconds. It has to be seconds for it to be called watts. This comes out as 1177 watts, which is going to become 1.2 kilowatts. Option B was the right answer. You can also use, since it's moving at a constant speed, you can also use P equals to FV. But I would like you to try this. How would you use that equation for this? Because speed is given, where might the force actually come from? Is it the weight? Is it the mg? It is. And if you do that, and why are we taking force as mg? Because it's moving at constant speed. That means it's going up with a constant speed. That means force upwards and force downwards are equal, leading to acceleration becoming equal to 0. If these forces are equal to each other, then definitely this one of them is going to be mg. In place of F, we have mg. In place of V, velocity is 12 meters divided by 60 is 12 meters per second. We get the same answer. If you notice, it's the same thing. Question number 21. This was again a very simple, straightforward question, and the examiner says students still found it difficult. Which term defines the quantity x? You see, it is extension. It is the change in length. But this is compression. This is exactly what happens to a car suspension. This is exactly what happens when you click your ballpoint pen. You're compressing down on the spring. So this shouldn't have been that big of a problem, but students still got it wrong. Load is the applied force that might have done this. The box is applying the load, which is mg, which is a force, which is w. So it can't be that. Strain is change in length over length. So we're not interested in that. If we wanted to find the strain, we could have done this. We could have measured the full length. We could have measured the x. Then x divided by L would have been strain, option C. But that's not what we're looking for. He's only asking me about x. Stress is force over area. No sign of this nowhere in the question. So the correct answer was option A. Question number 22 invokes that you know the equation resistance equals rho L over A. And I've said this, no, I think it's not for this one, it's for the next question. My apologies, this question requires you to remember the equation Young modulus equals to FL over AE. Now, I get this equation from the fact that it's going to be stress over strain, so this is force over area divided by extension over length. Some people like to write this down as F over A, X divided by L. If you manipulate this algebraically, then you will get to this equation. Instead of remembering them, I've remembered this. It helps me put the values directly into it and get the answers. It says the spring constant of the wire. Let's see how to manipulate this in the first place. So Young's modulus is equal to F multiplied by L divided by cross-sectional area multiplied by, let's call this extension E. I'm deliberately choosing E because it is different from X. If I write down X, it might be confused by the multiplication sign in my lecture. That's why I'm using E. If you're comfortable with X, it's completely fine. Now notice what is the spring constant. Spring constant is F from Hooke's law is F equals to Kx. K is F divided by X or F divided by E. So if I can somehow isolate this F and E in my equation, then I will be having spring constant on my hands. So let's go it that way. So force divided by E multiplied by length divided by A. This has become the spring constant K. Now, K multiplied by L over A is equal to Young modulus. K equals Y multiplied by A divided by length L. When you get this, it's a matter of putting in the values. Be careful about this being the diameter. Young modulus is 1.2. That's given here. Into 10 raised to the power 11. Area is pi r squared. So this will be 0.64 into 10 raised to the power minus 3 divided by 2 whole squared divided by the length of the wire or rod is 1.7. When you calculate this finally, your answer will be 22708 newtons per meter, which can be rounded off to 2.3 into 10 raised to the power 4. Yeah, that's going to be option A. Please perform the algebra correctly. I can't help you do that. Instead, I'm helping you how to understand and apply the equation. Question number 23 is again a repeated question. He says the extension varies. How much energy or elastic potential energy is in there? It is always going to be the area under which graph? Area under the extension load graph. That's important because you will see in some questions they will give you, instead of extension, they will give you the length. When it's about length, then we can't use this logic. We have to be smart about our choices and only think about the extension from the same graph to be able to do this. So this is simply 1 over 2 into base area, which is 30,000 or 30 kilonewtons. and multiplied by height, which is 4 centimeters. So this will be 4 into 10 raised to the minus 2. This answer comes out as 600 joules, which is option C to be the right answer. All right, let's move on to question number 24. He says progressive longitudinal wave. All right, so transfers energy. Yes, it does. It's true. Requires a medium of travel. Yes, that's also true. Longitudinal wave as sound require a medium. Always travel at the same speed. No, that statement is false. Why? Because as they encounter a different medium, they refract. And refraction is defined as change of speed due to a change in medium. The fact that light bends, and that's how we remember this, bending of light is a special case. The true understanding of refraction is change of speed due to a change of medium. So correct answer should be option D. Question 25 is interesting. What is the phase difference between P and Q? You see, if you start from this point and go to this point, one complete wave, this should be 360 degrees. And from this moment onwards, this is quarter of a wavelength, lambda by 4. Lambda by 4 multiplied by 360 gives me 90 degrees. So this is advanced by 90 degrees, which is 360 plus 90. That's all to it, this question. It was as simple as this. Nothing more complicated than this. If you wanted to find another alternative to 450, because we observe this as a unit vector, you could have added 360 again to this and gotten to the next best option. But that's not a case in this. We're getting 450 directly. That is the answer. 26 is a good question. Okay. All right. He said the density of wave x is I. Okay, fine. What is the intensity of wave y? So the question has a displacement or amplitude in this. And the equation for intensity is proportional to amplitude squared. What I could do is convert this equation to an equality as Ka square. First, I can find the K with the given data, which is wave x and I, and then use that K for a new situation. Instead, we're going to do another thing. We're going to use the technique employed from mathematics. Let's try to do that over here. You see, this is wave y, so I'm going to call its intensity as Iy. This is wave x, let's call this Ix. Its amplitude is Ay, and its amplitude is Ax. Do we have their amplitudes with us? Yes, we do. This one, if you read the graph correctly, is 0.4, and this one is 0.75. So we do have some values on the graph, which we can deal with them. So let's see how we got about them. Since we have this data, and we know that they're proportional to each other, we can make an equation from this, which is going to be Iy equals Ay squared divided by Ix divided by Ax squared. Now this is because of this proportionality. If I divide one situation with another situation, I equals to Ka squared, then K cancels out, which is why finding K does not serve any mathematical purpose to me. Although that's not wrong, the method is correct, but it takes me a lot of time. Ix was given to me as I. So I'm going to change the label and say that this is I now, and take this to the other side. So after doing that, what I'm left with is this. Iy is equal to I, that was Ix converted to this, multiplied by Ay squared, which is 0.75 whole squared, divided by Ax squared. The intensity of the amplitude of x was 0.4. So 0.4 whole squared gives me 3.5156, which is option, and since we have the I with it being multiplied, this is option D. Question number 27, he says, a moving source emits this, a stationary observer sound observes this, the frequency is decreasing, that means the object is moving away from us, the speed is 340, he says, find the speed of the object going away. First, it is moving away, so two words are cancelled. I am going to choose between A and C. So let's use the formula to solve this question. So this is what we are hearing. So this is going to be 960 equals the standard frequency that we couldn't hear, which existed, speed of sound, which is 340, divided by 340. Now, this is where you have to be clever about this. Since the answer is getting smaller, the denominator should be greater. So it's going to be 340 plus x. Or better still, if you memorized it, you can just use that formula in terms of that. Now, what I will advise you, that instead of doing the algebra, why don't you put these two numbers in the equation? It's 85 and 68. Put them here as going answer to question by using the same equation and see which one gives you 960. It's only 85 that gives you 960. But if you want to do the algebra, then be my guest. It's up to you. You should find x to be exactly 85 meters per second. No decimal, no nothing. Question number 28, he says a light wave passes through slits, diffraction pattern forms. What happens to frequency and speed of the wavelength? There is generally no change. So I would go with frequency no change, speed no change. Frequency generally never changes because it's controlled by the source, right? So option D will be the right answer. Question 29, diffraction grating formula given. He says which quantity is not correct. D is not the distance from the grating. It is actually the distance of the grating crystal. So this seems to be false. Lambda is the wavelength, true. N is order, true. Theta is angle intensity of the maximum, true. But from n equals to 0. So the most incorrect option is option A. Question number 30. He says two progressive waves move in opposite directions, superposed to form stationary waves. Okay, fine. Which statement about the antinode of the stationary wave is correct? The antinode is formed here. This is node, and this is antinode. This is where you find the maximum displacement. So let's see what the question is about. So position where the phase difference is about, no. Phase difference, you see, antinode, this antinode with the next antinode will be out of phase at 180 degrees. So the phase difference is being 0 is not a condition for this. You see the stationary wave established like this. This is the first phase, and this is the next phase. If I'm comparing this antinode with another antinode, they're exactly opposite to each other. And nodes don't vibrate, so they don't have a phase difference. So this first statement is incorrect. The position phase difference between two waves is always 180. Between two waves is always 180. No, it's not always 180. This is wrong. The fact that waves basically travel through one another. They're traveling towards each other, and then they travel or pass through each other. And as a result, the phase difference actually starts from 0 and goes to 360 completely. It's a complete check of all the phase angles. The position wave maximum amplitude node, that's antinode, and say is minimum amplitude is node. He's asking me why. Okay, so he's asking about antinode, says option C. Question number 31 again from diffraction interference. Signal generator P to Q, he says the loudness is varied. He notices loudness of the sound rises and falls. He says, why did this happen? Diffraction of sound waves. It is true, but not in this case. Doppler shift of the sound waves, no, completely false. Interference is a much better answer. Reflection of sound waves, no, reflection doesn't cause this. It's either option A or C, and the best one is going to be option C. The fact that diffraction is not required here because there is no narrow gap to pass through. The fact that what we wanted to achieve from the narrow gap is curved wavefronts. They already exist. Question number 32. It says the current was 8 milliamps and the power was P. So I'm guessing the formula that I'm supposed to use, I square R. He said the current of the resistor increased to, not by, it is increased to, be careful about this word, 12. What is the new power dissipated? Since we are increasing the current, it's not possible to have a smaller value of power. It's either going to be 1.5p or 2.3p. But anyways, let's move on. So the other idea of this question will be use this as equation 1. P equals to I square R, use this as equation 2. And then find the R and then go the long distance for mathematics. But we're going to do the same technique as we did for the wave intensity question previously. I'm going to divide these two equations based on their new information. Okay, so P dash divided by P, the letter P was given to me in the question, equals P dash, new power is 12 milliamps divided by 8 milliamps. And since this is current squared, the whole bracket has to be put squared with it. So P goes to the side. This becomes, if you calculate this, first divide 12 with 8 and then take the square. This is going to give you 2.25 I, which is going to become option D. Question 33 is another easy question, just in terms of variables. He says there is a resistance of X wire, resistance X, its rho length over area. Okay, fine. A second piece of wire, Ry, is made of a different material. So rho will be different, but the same resistance as X, but twice the length. So 2 times L divided by cross-sectional area. He says, how can we make sure that the resistance of both components stays the same? We want to get rid of this 2 so that we can get rho L over A again, because that is equal to R, right? That's what mentioned here. So by checking this as hit and trial, half resistivity seems good, because adding 1 by 2 gets rid of this 2. We can do that. But adding 1 by 2 with cross-sectional area, this goes up and makes it twice again. But this is the wrong choice. We can't use half area. We can't choose rho. We need half an area, half a rho, not 2 rho. So the best answer is going to be option B. Okay. Question 34. An EMF. What is an EMF? This is basically a definition point of view, from the point of definition. Okay. So how would you deal with this question? What do you think that is? Which statement is correct? Let's see. The energy dissipated in the external circuit is EQ. Okay. This seems right, but let's see. Energy dissipated within the cell is EQ. No. The external resistance is EQ. No. Basically, this is diving on this equation. Voltage is equal to work done divided by charge. If you look at the work done, that should be Q multiplied by V. It's generally delta V, change in voltage. But anyways, the total energy dissipated in the cell and external circuit is EQ. This seems to be the better answer. The external and internal. So in external circuit, no, this is wrong. That's why I was confused that the statement looks right, but why is it wrong? This is the reason, because we're looking for dissipation inside the cell as lost volts, and to the external circuit is EQ, yes. So for the whole circuit, the battery has to do that job. The battery has to do that work, so it's going to be option D. 35. He says the resistance of the fixed resistor is 20 kilo ohms, and the voltmeter connected to voltmeter, the thermistor is 20 kilo ohms. This is also 20 kilo ohms. He says the temperature decreases. Now, this is where you're supposed to remember that resistance of an LDR is inversely proportional to light intensity. If the is thermistor, so this is going to be temperature. Now he says that the temperature decreases. If the temperature decreases, the resistance increases. But by how much? Increase or change by, now this is very clever. He says change by 50%. He's not giving you the answer directly. Has it increased or decreased? So you need to employ this knowledge that you've already have before you answer this question. So this is 20, but with a change of 50%. So 50% of this is 10 kilo ohms. Since we predicted that the resistance is supposed to increase, this is going to be 20 plus 10 going to 30 kilo ohms. Now he's asking me, what is the change? After this change, what is the new reading on the voltmeter? So we don't need to find the previous reading. We only need to concentrate on the current reading. So at the current situation, the resistor that is connected to is only 20 kilo ohms with a voltmeter like this. And the next resistor that is connected is 30 kilo ohms. We can use the potential divider formula, which says the resistance of the component that you want to find the voltage of goes in the numerator. So this is going to be 20 kilo ohms. Divide this with the total circuit. And the total circuit resistance is 20 and 30. So this is 20 plus 30. I'm writing them separately for the sake of your concept. And then multiply this with the battery source voltage that is supposed to be divided. So when you solve this, your answer naturally comes out as 24. Now notice that I am not interested in the kilo factor. Why? Because in the numerator it exists and in the denominator it also exists. So it doesn't really matter. Okay, so it's going to be option B. Now, question 36 is again a repeated question. It has been repeated. I've seen this question at least third or fourth time in the past papers. So be very careful. So he wants to find the EMF of EX, unknown cell, and E0 is a known cell. The fact that setup works we are relying on the fact that, for example, for the sake of example, if we had a single battery like this one, which is 5 volts, and we connected this to the wire or across a wire like this using crocodile clips, what do you think is going to happen to the voltage? You see, this is positive and negative. When the electron enters here, the voltage is 5, but when the electron enters here, the voltage is 0. So the wire consumes all the voltage. If I want to find the voltage of an unknown cell, or be irrespective of that, what would happen, do you think, if I connect a voltmeter between 2 points of the wire? What do you think is going to happen? Voltmeter tells me the voltage is going to measure that the electron existing at this point and the electron existing at this point, how much energy deficit do they have? So that means as the electron goes along, it loses energy, 4 volt, 3 volts, 2 volts, 1 volt, and then eventually 0. And the story doesn't end here. What about the between 4 and 5? So 4.9, 4.8, 4.5, 4.6, 4.3, 2, 1, 0. So it's happening at every level. We're taking advantage of this fact that the voltage is equally divided generally on the whole length of wire. Now, how do we set this up? What's the problem and what's the get-go? So first, the terminals should be the same. So if this is positive, the other terminal connected to the battery should also be positive. It's not, so we reject this option. Second, why are we rejecting B? You see, it is supposed to be connected. So E0 was the known cell. EX is the unknown. So it's the unknown that is supposed to be, linked with the ammeter. Part C, the ammeter is connected to the wrong location. Reason being, we are not measuring the current of the circuit. We want to measure the current of this circuit. This one seems plausible. So the positive is connected with positive, negative with negative, ammeter with the unknown cell, and movable junction going this way or this way. If you want to find, for example, when do you find the voltage? The voltage of EX. How do you find that? He says that the current on the ammeter becomes 0. There is no amp, there is 0 amp of current. When there is 0 amp of current, that means that the voltage of EX and the voltage section in this section has become equal. So we find this by taking the ratio of lengths. So this length, P to J, divided by P to Q, multiplied by the E0, the EMF, will give me the information of EX. This is a formula for P2. So the best answer is going to be option D. Question 37, it's a fact-based question. We are not wasting time on this. It's doing first law is about charge, second law is about energy, which is dealing with voltage around a complete circuit. Question number 38, an up quark is made in a hadron, changes to a down quark. The elementary charge is E. What is the magnitude change in the charge? The change confuses you. The up quark is, if you visualize this on a number line, the up quark is positive 2 by 3e, then gets 0, then gets minus 1 by 3e, which is generally a down quark. He says an up changes to a down. What is the change in charge of the hadron? So the change is this. It could have been 2 by 3e minus 1 by 3e, leading to a complete E. You can use calculator for this. It's going to be C. Part 39, he says decays to form nucleus sodium-23, emitting B positive. Particle X, what is particle X? It's going to be a neutrino or antineutrino. You see, for the positive, we have a neutrino. Now notice what he's done. Wordplay to cause confusion. An antineutrino is basically with beta negative decay. So it's a memory-based question. Nothing to think more than that. Question number 40 is a good calculation question. He says, uranium this decays to become this. How many alphas and betas must have been emitted from uranium to lead for this to be able to be done? So first, uranium is 238. This is 92. Now, how many alphas need to decay first? 4, 2. So that it becomes lead 206, probably. Yeah, 206 and 82. You see, since it's alpha and beta, alpha is 4, 2, beta is 0, minus 1. Beta cannot change the nucleon number. Beta does not interfere with the nucleon number. The only thing that does interfere with the nucleon number is alpha. So if I take the difference of 238 and 208, and divide this with 4, I can find how many alphas went out. So 236 minus 206 gives me 32 divided by 4, because we can find the number of alphas. This comes out as 8. So number of alpha is 8. Now, alpha didn't just remove or change the nucleon number, it also changed the proton number. So 92 and 82, we can simply say that, is this 82? How much change should that be? Now, we can't do that here. First, we need to go back again for the sake of alpha. You see, if this is 238 and this is 92, minus 8 alphas, which 4 and 2, so this is 8 times 2 subtraction 92, that gives me 76. So whatever is being made intermediately should have 76 in it. Yeah, it should be 76. So what happened was uranium-238, 92 decays with 8 alpha 42, makes something X, which is 206, with proton number as 76. Now then goes the beta decay, 0 minus 1. It doesn't disturb the number up top, which is the nucleon number, which is lead 206. But from 76, we can see that the number of lead for proton number is 82, which means that it has increased in number from 76 to 82. And the only one who could change this is beta negative decay. So how many were there? So 82 minus 76 divided by 1, probably. Yeah. So this, if you subtract them, the answer comes out as 6 or 8. Yeah, this is going to be 6. 82 minus 76 is 6. Yeah. So it should be 6 beta particles. That is 6 and 6. And the common answer is option A. That is all for today. I hope you learned something. I'll see you in the next video.